Would you believe me if I told you that in Tlemcen, some mills were part of the tourist circuit, just like the most famous ruins? This was the legacy of ancestral know-how in a region known for having once been the granary of Rome. Here, milling was not merely an industry, it was an art, carved into stone and the movement of water. On 29 April 1887, readers of the Courrier de Tlemcen came across a rather unusual feature. Before even celebrating the city's monuments, the journalist marveled at the mild climate and the omnipresence of water. He also gives the mills a place of honor, inviting tourists to venture up the mountainside to follow a circular route, from the mills of El Kala to the Boumediene Canal via the Mississippi Mill. Yet, returning today to the waterway carved out by the Oed Mechkana and the Sakia Erumi, the reality is a bitter one. A century and a half later, this mechanism has fallen silent. These mills, once clinging to the hills of Tlemcen, are now nothing more than silent ruins, sometimes turned into rubbish dumps, erased from our rural landscape.
But whilst the stone may crumble, the science of motion remains. One question springs to mind. Why did the majority of the mills on the Al Mechkana operate with a vertical bucket wheel, whilst those in the El Urit Mountains used a horizontal water wheel? It is neither a question of flow weight nor of head. The answer is purely technical. It comes down to space. Whereas a vertical wheel requires extensive facilities, the horizontal water wheel stands out for its compactness, a strategic choice for fitting into the steepest slopes of our mountains. Let's venture into the bowels of these mills. Water is channeled to the intake canal, situated above the mill, from the Sakia Erumi down to the inlet. It falls vertically onto the water wheel, and it is here that local engineering reveals its full ingenuity. To be effective, this drop must be precisely calibrated to between 3 and 5 meters.
If the drop is too low, the water wheel lacks power. But if it exceeds 5 meters, the speed of the jet becomes destructive. The millstone spins out of control, turning at such a rate that the friction eventually burns the flour, altering its taste and properties. It is all a question of balance. Over 4 meters, the force at the outlet is almost doubled. The jet, guided by a nozzle, strikes the bronze spoons of the horizontal wheel with the impeller. The lower end of the wooden shaft, attached to this wheel, turns with it, whilst the upper end is firmly anchored in the upper millstone, drawing it into its rotational movement. The upper millstone is pierced at the top to allow the grains of wheat falling from the hopper to pass through. They are ground against the fixed lower millstone, and the flour flows through the gap between the stones. Everything is precisely calibrated, the result of local hydraulic expertise. The water from the Mechkana Wadi, the driving force behind the mills of El Kala, is diverted into a supply channel before striking the buckets of the vertical water wheel. Driven by the force of the water, the wheel rotates on its horizontal axis. Unlike the water wheel, the mechanism here is more sophisticated. It must convert horizontal motion into vertical rotation to drive the upper millstone. This transition relies on a wheel whose teeth, or oluchants, fixed to the wheel, mesh with a wooden ring, thus forming a robust gear mechanism. The resulting mechanical friction absorbs some of the energy and requires regular maintenance. It is this technical complexity, combined with the necessary size of the gears, that explains why the vertical wheel requires a much larger space than the rodette system.
Beyond the mechanics, what about efficiency? Given the rigor required by hydraulic analysis, it must be noted that this water is not consumed, it merely passes through. It flows further downstream, either into the Sakia Erumi or the Wadi towards Pomeria. However, the efficiency differs. The water wheel mill has a modest efficiency, between 15 and 25%, requiring 1,500 to 2,000 meters cubed of water to grind a quintal of wheat. However, despite these differences in flow rate, The time required to produce 100 weight of flour remains the same for both systems, ranging from 2 to 4 hours. In contrast, the bucket wheel uses the weight of the water and gravity to achieve an efficiency of 85%, thereby reducing the volume of water required for the same result by 2/3. This profusion of mills in Tlemcen reveals a major historical reality. North Africa was a vital link in the imperial supply chain, a system designed to meet a constant demand to feed a vast and dependent urban population. This colossal production required processing on an industrial scale, giving full meaning to hydraulic engineering. Every wadi, every waterfall became an opportunity to grind the wheat destined to cross the Mediterranean. Beyond the technical aspects, these installations were the cogs in a much larger machine, the cura annonee, the imperial administration that orchestrated Rome's food supply. The wheat, collected as a tax in kind, then passed through these mechanisms, the rodette or vertical wheel, which became the links in a vital supply chain. The remains of El Kala and El Arit thus bear witness to a strategic response to the incredible abundance of our plains and the insatiable needs of the empire.
In Pomaria, water is not merely an element, it is a feat of engineering that spans the centuries. Revived and adapted in the Middle Ages, this hydraulic ingenuity lives on in the mills that now stand abandoned. They remain a living testament to a tradition born of the ingenuity of the indigenous people, an art of movement which, despite the silence of the ruins, continues to tell us our own story. What if these ruins were not merely vestiges of the past, but the traces of a journey that could be reborn? On the ground, the Benauda Mesifi mill is a particularly telling example. Its state of disrepair is only partial, and its preservation is still possible. Its load-bearing walls, built of rubble-stone masonry, are, however, still largely standing, clearly outlining the building's intact volume. The wooden framework, also still in place, retains the memory of its original structure. Only the roof has suffered significant damage. Nearly half has collapsed inwards, as if the building had closed in on itself. Through this opening, the mill's interior is revealed, marked by time, damp, and neglect. The mill trail could thus once again become a living route linking memory and the local landscape, if a restoration project were possible. This episode devoted to the mills of Tlemcen is drawing to a close.
But one question remains. Once it reaches Pomaria, what becomes of the water? How is it shared, distributed, and managed? That's what we'll find out in the next episode.